Okay, in this lecture I want to go over an example using the stuff that we learned in the first two lectures. Okay, and we're going to look at this pair of parametric equations. X equals negative 3 t squared plus 9. Y equals t cubed minus 3t. And what we're going to do is we're going to use calculus to figure out what we can about this curve. Okay? So the first thing I want to do is draw some axes. So that as we find stuff out, we can add to the picture. Okay, now, where do you think we should start? I think that when you're given a function for x and a function for y, the place to start is to write down the derivative of both of those. Okay, so I'm going to write down dx dt and dy dt. So, what is dx dt? X is negative 3t squared plus 9. So the derivative of that with respect to t is negative 6t. What's dy dt? Y is t cubed minus 3t. So the derivative of that with respect to t is 3t squared minus 3. Okay, good. Now, we can use that to find dy dx. Okay, do you remember the formula for that? Dy dx equals dy dt divided by dx dt. Remember from the last lecture? And so what are we going to get here? We're going to get 3t squared minus 3 divided by negative 6t. Let's go ahead and simplify that. And we'll get t squared minus 1 over negative 2t. And let's go ahead and rewrite that as 1 minus t squared divided by 2t. So that's dy dx. We can use that to find local minima and maxima. We can also use it to find out when the graph is vertical. Okay, so let's do what we learned in calculus 1 for finding maxima and minima. Let's take that derivative and set it equal to 0 to find critical points. Okay, so one second here, I'm having trouble with my pen. Okay, so when does dy dx equals 0? That's the question we want to ask. Okay, so let's just work it out. 1 minus t squared over 2t, set that equal to 0. We get 1 minus t squared equals 0, which means t squared equals 1, which means t is positive or negative 1. That's the two places where the derivative is 0. So now, here's what you do when you have parametric equations. To find the points on the graph, that correspond to different situations. You take the values of t and you plug them into the equations for x and y. Okay? So what I'm going to write here is I'm going to say when t equals 1, let's actually do a negative 1 first, okay? Okay, what point does that give us? So look at our equations for x and y. Plug in a negative 1. When you plug a negative 1 into our x equation, we get 6, don't we? And when we plug a negative 1 into our y equation, go ahead and work that out, we get 2. So when t is negative 1, we will arrive at the point 6, 2. Let's write that down. Okay. What point do we get when t equals positive 1? Let's do the same thing. Let's go up here. Plug positive 1 into here. And we're going to get 6 again. Plug positive 1 into here. And we're going to get negative 2. So when t is 1, we're at the point 6, negative 2. Okay? Those are 2 points where the derivative is 0. So the graph will be horizontal at those 2 points. So let's plot those in the picture here. Okay, let's go over here. 1, 2, 3, 4, 5, 6. And we had 6, negative 2 and 6, positive 2. So those 2 points are on the graph. And I know that the graph is horizontal at those 2 points because the derivative is 0. And let's write in gray the values of t that produced those. I forgot which one's which. Let's see. The top one is when t equals negative 1. And the bottom one was when t equals positive 1. Okay? All right, now, what else would I like to do? Let's put a little line here, by the way. What color should we use? Let's just use a red line. I'm just going to put like this to indicate that the tangent line is horizontal at those 2 places. Okay, now let's look at what else can you use the first derivative for. What I like to do is write down any place where the first derivative is undefined. Okay, because what does that tell you? The tangent line has an undefined slope, which would tell you that the tangent line is vertical, right? So that's the next question. When is dy dx, which I'll just write down this formula here, undefined. Now remember, derivatives are limits. And sometimes you find out that a limit doesn't exist. I'm going to write this neater, it's kind of messy. Do you remember from Calculus 1 that if you're graphing something and if you have a cusp like that, the derivative will not exist right there? Okay, that's not what I'm finding right now. What I'm finding is, when is this formula for the derivative undefined? That will tell me when the graph is vertical, when the tangent line has an undefined slope. Okay, and this is pretty easy to answer, isn't it? Look, it's 1 minus t squared over 2t. That is undefined when t equals 0, right? That's pretty easy. Let's find out what point would we be at when t equals 0. So we go back up here again, plug 0 into here and here, and it's easy to see that we would get 9 for x and 0 for y. So when t is 0, we would be at the point 9, 0. Let's just go ahead and put that in the picture. Okay, so that would be right here. So that's the point 9, 0, and that happens when t is 0. Okay, and also the tangent line is vertical at that point. All right, excellent. So what else can we do? Let's find a second derivative to test for concavity. Okay, or would you rather do this first? Would you rather find x-intercepts first? Because we just found one x-intercept, didn't we? Why don't we do that? Why don't we see if there's any more x-intercepts? Okay. Remember now, we already found one. How do you find x-intercepts? X-intercepts occur when y is 0, right? So let's look at our equation for y and figure out when is that 0. Okay, so we take t cubed minus 3t. Set it equal to 0. Let's factor out a t. Factor that the rest of the way. So what do we find? We find that we have x-intercepts 3 times. There's an x-intercept when t equals 0, which we already found, by the way. There's an x-intercept when t is negative square root of 3, and there's an x-intercept when t is positive square root of 3. Okay, now remember right here, we already plugged in 0 for t and found our point. It was 9, 0, and we already put that on the graph. That was one of our x-intercepts. Okay, let us now plug in negative square root of 3.
Yeah.
Okay, let's go up here to our original equations. plug in negative square root of 3.
Yeah, the car.
Now we already know y is going to be 0. Don't worry about that.
Yeah.
You just have to plug in negative square root of 3 into the x equation.
Yeah.
Okay. Notice what you're going to get. You're going to get negative 3 times 3, which is 9, plus 9, which is 0. So when t is negative root 3, we are at the point 0, 0. Let's put that in a graph.
You should have made all the answers correct.
Okay, that's the point 0, 0.
Yeah.
And that happens when t equals negative square root of 3. Okay, now one more x-intercept, I think, right? Look down here. Looks like there's going to be one more x-intercept. Let's find that. So now we're going to take positive square root of 3 and plug it into these equations up here. Now remember, y is going to be 0. But take the square root of 3 and plug it in here. Notice what you get. You're going to get negative 9 plus 9 again. You're going to get 0 again. So look at that. This is interesting. Let's go down here and write that down. The graph passes through that point twice. Once when t equals negative root 3, and again a second time when t equals positive root 3. Isn't that interesting? So this point right here, the curve is going to pass through there 2 times. That's interesting. How about if we find out what angle is it going through? Does that make sense to you? What I mean is when the curve passes through this point the first time, t will be negative root 3. Let's find out what the slope is when it does that. That's not difficult. We just take negative square root of 3 and just plug it into dy dx and see what we get. Okay, so I'm going to take negative square root of 3 and I'm going to plug it into here. Let's see what we get. We'll get 1 minus 3 over 2 times negative square root 3. So that's going to be negative 2 over negative 2 root 3. So we get 1 over root 3. So that's the slope of the curve when it passes through the origin the first time. Okay, that's going to be something like this. Let's not worry about being perfect. Okay, that's when t equals negative square root of 3. The curve will pass through the origin and be at approximately that angle. So I'm going to go down here and write that down. I'm going to write slope equals 1 over square root of 3. Okay, now let's do the same thing. When the graph goes through that point, the second time is when t equals positive square root of 3. So let's erase that negative sign then. Sorry. Maybe I should have just erased everything and rewrote it. There we go. So what do we end up with? We end up with negative 2 over 2 root 3, so that's negative 1 root 3. So you see the slope is going to be kind of symmetric to the last one, except it's going to be at that angle instead. That's when t equals positive root 3. The curve will pass through that same point again, but it'll be at a different angle. Okay, let's write that down here. When the curve passes through the origin the second time, the slope will be negative 1 over root 3. Okay, good. That's very good. Okay, let's erase some of that stuff now that we're finished with. What else can we do? We can find concavity, can't we? How do you find concavity? Use the second derivative. You remember how to do the second derivative with parametric equations? Look at that nice chart from the end of lecture 2. The second derivative of y with respect to x 2 times. How do you do that? It's the derivative of the first derivative with respect to t divided by the derivative of x with respect to t. Okay, so that means it's the derivative of, what's dy dx? 1 minus t squared over 2t. So we want to find the derivative of that. With respect to t, and then divide that by the derivative of x with respect to t, which we already found. There's no need to work it out again. It's right there. dx dt is negative 6t. Okay, so now for that top one, I'm going to have to use the quotient rule. Okay, the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. And then that whole thing is then divided by negative 6t. Now this is just algebra. Go ahead and multiply that out, okay? And simplify it. If you need some time to do that, go ahead and pause the video for however long you need. Okay. What I got was, I narrowed it down to negative 2t squared minus 2 divided by negative 24t cubed, and then that simplifies further into t squared plus 1 over 12t cubed. Okay? And we're going to try to find concavity, so we want to know when the second derivative is negative and when it's positive. And that's easy for this one. So look at this. Do you notice that that will be negative when t is negative? and it'll be positive when t is positive. Okay, so what's that tell us? T is running along through all of the real numbers. And when t is negative, we're going to have a curve that's concave down, and then when t switches to positive, the curve will become concave up. Okay? And we already know that the curve goes through those 4 points, and we know what the slope is when it passes through those 4 points. Okay? One more thing I would like to do before we finally graph this thing is I would like to find out, these are just my words, the book doesn't use this wording, this is just my words. Where does the curve come from originally, and where does it eventually go to? In other words, what I do is I find the limit as t goes to negative infinity and the limit as t goes to positive infinity. Okay, so let's walk through that. They're very easy limits. They're really easy. Okay, so I'm going to write this question. Where, whoops, that's not how you spell it. Where does the curve come from? Now, sometimes they give you a finite range for t, like they'll say t goes from -5 to 5, okay, in which case you can just find the 2 endpoints. But on this one, t is unlimited, so it can go back as far as negative infinity and it can go forward as far as infinity. Okay, so what I do is I find the limit of x as t goes to negative infinity. Okay, that's a super easy limit. Remember, x is simply -3t squared plus 9. And so the limit as t goes to negative infinity is negative infinity. Okay, and let's find the limit of y as t goes to negative infinity. Okay. Okay, remember y is just t cubed minus 3t. So as t goes to negative infinity, that limit is negative infinity. So I answer that question, where does t come from? I mean, where does the curve come from? I answer it like this. I say it comes from negative infinity, comma, negative infinity. Now this is just the way I say it. You won't see this in the book because first of all, there's no such thing as negative infinity, negative infinity. But my point is this. Let's look back at the picture. Here's my point. Look at the values of t that we have written down so far. I have written down a point when t is -3, a point when t is -1, a point when t is 0, a point when t is 1, and then a point when t is +3. In this order. Let's do this kind of like a connect the dots. So that point right there, that would happen first. Of these 4 points, that would happen first, right? And then this point would be happening next. And then this one. And then this one. And then this one again. Right? Now, when I say the curve comes from negative infinity, comma, negative infinity, that is down in that direction. So what I'm saying is that the curve is coming from here. That's what I'm saying. Okay? Now, let's find out where the curve goes to. That's just as easy. Where does the curve go to? So we just do the limits of x and y as t goes to positive infinity. Okay, go ahead and work out those limits and see what you get. You should get negative infinity for this one and positive infinity for this one. So the curve goes to negative infinity, infinity, which is not really a point, but let's look back at the picture. And what I mean when I say the curve goes to negative infinity, infinity, what I mean is that after the curve goes through these points that we've marked, it eventually is going to leave the page just a second, sorry, it's, whoops. Okay, let me fix that. It's going to leave the page going off there. Okay? So let's graph this curve. I think we can do a pretty good job of graphing. Okay, I'm going to erase these two blue arrows there. Okay, so here we go. It's going to come from this direction. Notice there's an order in which I'm drawing this. The order is as t gets bigger and bigger. Okay, I get a certain direction. The graph's going to come up here. It's going to pass through the origin at that angle. I kind of missed it. Let me see if I can do a better job of that. Let me start over with that. Oh, and also, by the way, when t's negative here, remember it's concave down as well. So let me put a bit of a curve to it there. Concave down. Going through there. Concave down. It levels off right there. Still concave down. Goes through this point vertically. Now it switches to concave up. It goes through that point, levels off, concave up, goes through the origin again at that angle, still concave up, and goes off in that direction. That's what the graph looks like. Okay? Let's get rid of some of the extra markings there, and the picture will look neater. It's kind of like a fish shape. And like I said, it's important to notice that it has a certain direction to it, and the direction is this direction. Okay? There you go. Now, one thing I notice is that there's a loop in this, isn't there? So it might be worth practicing here, and it might be interesting to just find out how long do you have to travel to go around that loop? In other words, what is the arc length of this loop? And also, what is the area enclosed by that loop? Okay, let's calculate those two things. I'll try to do it over here on the side. So let's find the arc length of that loop. Remember from our previous lecture, there's a formula for arc length. We integrate the square root of dx dt squared plus dy dt squared. And let's put our starting value and stopping value of t. That loop begins when it passes through the origin when t is negative root 3. And then that loop closes off when t passes through the origin the second time. I mean, when the curve passes through the origin the second time, which is when t is root 3. Okay? All right. This is actually an easy integral. Take a minute to just work this out inside here, okay? Pause the video if you need to. Just work that out and see what it is inside the square root. Okay, you should get 9 t to the 4th plus 18 t squared plus 9. Now that's factorable. That is actually t squared plus t plus 3. Sorry. Let me say that again. That is 3t squared plus 3 squared. So what would the square root of that be? The square root of 3t squared plus 3 squared is 3t squared plus 3. So you might remember I said this was an easy integral, and the reason I said that is because I see now that all we're integrating is 3t squared plus 3. And I think you would agree that that is an easy integral. Okay, what's the antiderivative? The antiderivative is t cubed plus 3t. T is going from negative root 3 to positive root 3. So we're going to get 6 root 3. Work this out yourself, okay? Don't just take my word for it. Work it out yourself. Plug in the square root of 3. You should get 6 root 3, and then minus, and then we'll get negative 6 root 3. So that's 12 root 3. That's the length. That's the length around this loop. Is 12 root 3 units. That's approximately 20.7 units of length. Okay? Let's find the area enclosed by that loop. Okay, I'm going to erase that problem that we just did there. You can always rewind the video if you want to see it again. Let's use that same space to find the area enclosed by that loop. And something really neat is going to happen here. Okay, so what's the formula for area? You integrate y times dx dt. Okay, so that's going to be t cubed minus 3t times negative 6t. Okay, that's an easy integral. That's just going to be negative 6t to the fourth plus 18t squared okay, we integrate that, get negative 6/5 t to the fifth plus 6t cubed. T goes from negative root 3 to positive root 3. We're going to get 36 root 3 over 5 minus negative 36 root 3 over 5, which is 72 root 3 over 5. That's how much area is inside that loop. Okay? Now, I want to talk about that for a minute because this is more interesting than you might realize. Isn't it usually the case that, whoops, I didn't mean to erase that. Isn't it the case from Calc 1 that this area would be positive because it's above the x-axis, and this area would be negative because it's below the x-axis, and it's a symmetric picture, so wouldn't you have expected that area to, those two halves to cancel each other out? Same size, one positive and one negative, wouldn't you have expected to have an area of 0? But we didn't. Isn't that weird? Why? Why not? Well, let me show you why. It's a very simple explanation, and this is really interesting. Remember, t is changing as we go along. And remember, it's starting here and it's going that direction. So what I'm going to do is I'm going to make a nice thick purple line here. And we're going to follow this along. Our curve's coming along this direction, okay? Coming along, coming along. Now, it starts the loop right there. It's doing this loop. And as it's going from negative root 3 to 0, it's tracing the top of this loop. And as it's doing that, we are accumulating this area. Do you know how much area that is so far? It's right here. That's the 36 root 3 over 5. Okay? Now, this area down here, you should expect to be negative 36 root 3 over 5. But, here's the catch. Watch what's happening. As I trace the curve, as t continues to grow, look, it's tracing out that, but look, I'm going now from right to left. I'm going backwards. I mean, I'm following the blue line in the correct order, but I'm traveling backwards along the x-axis. So what's that mean? Means that area is, in Calc 1, you would have calculated that area to be negative 36 root 3 over 5. But because we were traveling from right to left, the sign changes. And so that comes out as a positive 36 root 3 over 5. You see? So it is under the x-axis. That's true. So there is that one negative sign. But we were accumulating that area from right to left. So the sign gets changed, and the two negatives end up canceling out, and we end up adding on extra area. Isn't that interesting?
Yeah.
So that total area inside that loop is 72 root 3 over 5. Okay, now one final thing to do, and this is going to be short. I want to make sure that you are comfortable calculating. I'm going to have to redraw this picture, okay? I want to make sure you're comfortable calculating the tangent line at any location. And I'm going to introduce you to something new, which is called the normal line. Okay?
Yeah. Well.
So let's pick a point. Let's say when t is 1/2. Where would that be? That would be right about here, right?
Yeah, I hate getting my blood drawn. I've only done it once.
When t is 1/2. What I want you to be able to do is I want you to be able to calculate the tangent line at that point. Let's erase some of this other stuff here.
I can't look at it. I gotta.
Okay, let's calculate the tangent line.
I have to avert my eyes and think.
All I need to know is the slope, and I need to know what point that actually is.
If I look at it, I will get sick to my stomach.
So let's find that point. Okay, I'm going to erase a bunch of other stuff that we finished with.
Yeah, I don't like watching needles go into people's skin. Like I don't have like a problem with just like needles, but
Okay, get this stuff out of our way. All right, so let's plug in t equals 1/2, and we're going to find that point. Okay, so x is -3 times 1/2 squared plus 9. So that's -3/4 plus 9,
anatomy is easy. All
which
you
is
do like,
8 and 1/4.
just read through this obvious thing. No, we didn't
Okay.
actually get to work on it today. We just read through.
Actually, let's not write it as a decimal. Let's write 8 and 1/4, so that would be 33/4.
And as you eat a brain, then
Okay.
as you eat the different part of your brain,
Why
your body starts growing.
is 1/2 cubed minus 3 times 1/2?
Your left.
So that's an 8
No, it's not our brain. Somebody else's.
minus 3/2.
But then, like,
That's
by
an
the end-
8th
by the end,
minus
by eating
12/2.
we've actually turned into a zombie.
I mean 12/8, sorry. So that would be -11/8.
Hear and
Okay, so that point right there is 33/4, comma, -11/8. Okay, now what is that tangent line? Well, it's very easy. I just need the slope and the point. What's the slope of that tangent line?
Yeah.
Here's the derivative right there. So the slope would be 1 minus t is 1/2,
You know, like,
1/2 squared over 2 times 1/2. So that's 1 minus 1/4 over 1, and that's going to be 3/4. That's the slope of that line. So what is the equation of that purple tangent line? Y minus the y value equals the slope times x minus the x value. So that would be y plus 11/8 equals 3/4 x minus 99/16. So that would be y equals 3/4 x minus 99/16
So like, yeah, I just
minus 11/8,
my,
which is 22/16.
biology.
So that will be
Probably transfer to
y equals
pharmaceutical school because like
3/4 x
pretty cheap, and since my parents work there, I'll get
minus 121/16. That's the equation of the tangent line, and you should be able to find that. Okay, now there's something else that's mentioned in the book you might not have seen before, but let's talk about that real quick. That's called the normal line, which is the line that goes through that same point perpendicular to the graph. Well, that's really easy to find. We don't have to do much more work.
It's pretty ridiculous.
We already know that point, 33/4 comma negative 11/8. And if the purple line has a slope of 3/4, then the line perpendicular to that, let me make this smaller, would have a slope of negative 4/3, right?
Yeah.
So that line will be y minus the y value equals the slope times x minus the x value. So we have y plus 11/8 equals negative 4/3 x plus 132/12. So we get y equals negative 4/3 x plus 132/12 minus actually 11/8. Now we need to work that out. 132/12 minus 11/8. Let's see here. First of all, I see that I actually made that a lot harder than it is. That number is actually just 11. I should have reduced it. I didn't recognize it as being so easy. It's just 11. So 11 minus 11/8 would be 77/8. Plus 77/8. And that's the normal line. You should always be able to find the tangent line and the normal line at any point. Okay? The normal line is not really important right now because we're only working in 2 dimensions, but when we start working in 3, it's going to be just as important as the tangent line. Okay, so that was a long lecture, but we were able to go through everything that we've learned so far and apply it to that one curve. So you see, you should be able to find all sorts of stuff about a curve. Okay, and this is going to be the end of our parametric equations. We're going to move on next and do something called polar coordinates. Have a good afternoon.